The A+ certified technician needs to know about a number of operating systems. The Microsoft operating systems are fairly important, and they're tested quite heavily. CompTIA goes back as far as Windows 2000. Also, Windows XP is fairly important, and Vista has been added to the new set of exams. So here we'll start in Windows 2000 and look at a couple of the key features. Just like modern operating systems, Windows 2000 had the Start button and the menu behind that. One of the most important areas is Control Panel. You'll find that a number of features, or applets as they're called, these icons in Control Panel, are important for you to understand. We'll take a look mainly at the System applet. By double-clicking the System applet, you come up with System Properties. It's also important for you to know how else you can get into the System Properties. The primary method used by most is not to go into Control Panel, but instead to right-click on My Computer and choose Properties. The effect is exactly the same, but you'll see that doing it this way tends to reduce the number of steps. Also in the Control Panel you'll find a couple of applets that have alternate methods of opening as well. For instance, the Display applet brings you into your display properties, and you may recognize some of these tabs. Alternatively, you can right-click on any unused area of the desktop, not on an icon, not on a program, not on the taskbar start menu down here, but just in a blank area of the desktop. Choose Properties. That gets you to the same place. Additionally, if we double-click Network and Dial-Up Connections, you see your LAN connections and any dial-up connections that you might have. Another way to get there, however, would be to right-click My Network Places and choose Properties. Exactly the same effect again. Let's take a peek at the System Properties and just make sure that we get the gist of the tabs that we find in there and any of the utilities that can be run from within. The General tab gives you information about your system. It doesn't really give you the opportunity to change any of this information, but it does give you a quick resource for information that you might otherwise need to go into the registry to find, or not be able to find at all. For example, it tells you that your operating system in this case is Windows 2000, that we're running Service Pack 4. Service Pack is just a series of updates combined together and produced as one package. It includes all the previous service packs as well as any of the interim updates that you might have installed up to that point. We also see that the computer information is given here, things like the CPU and its capabilities, as well as the amount of RAM that's installed. Here we see 128 megabytes of RAM is installed on this system. You also see who it's registered to, and the registration number is not to be confused with the installation key that you need while you're installing Windows. This is just a unique ID that is indicative of who the installation is registered to in this case. The Network Identification tab gives you a couple of buttons that you can use to join this computer to a domain, and they work in slightly different ways. If you wanted to change the name of the system, you could do that with the properties, as well as join a domain here, and with the Network ID button, that would push you into the domain information a little bit more quickly. The Hardware tab is fairly important. It's got a number of very high profile buttons and wizards that we can use here. Now, the Hardware wizard in Windows 2000, that's not seen in XP or Vista. This gets you into your Add Remove Hardware. So you see you can add or troubleshoot a device, uninstall, unplug a device. You can do the same thing from the Control Panel by double-clicking Add Remove Hardware. The exact same wizard pops up. So that's just your choice as to which of those you decide to use. But that is here on the Hardware tab. Down here under Hardware Profiles, a hardware profile can be thought of basically as a choice of hardware that will be enabled at boot up. And you always have a profile, but if you add multiple profiles, you can choose between those during the black screen boot phase when you start the computer. And what a lot of folks tend to use this for is for docking and undocking laptops. If you have a docking station that takes PCI cards, let's say, and you put a PCI NIC in your docking station or some other card, doesn't matter what it is, that shouldn't be available when you undock the laptop. You would want to be able to choose that profile only when the laptop is docked. When it's undocked, you don't want Windows to be looking for that device driver and trying to load it every time you boot, not unless you need it. Under the Device Manager section, there actually is a Device Manager button as well, and that opens what we call Device Manager. So that is something we'll look at in a little more detail. Driver signing is the other button, and that showed up with Windows 2000 and continued on into Windows XP. You don't really have that in Windows Vista. There are ways to go around through the command prompt and tell whether or not you want driver signing to be important with Vista, but that's not really a testable item. So driver signing gives us some options. We can choose to ignore unsigned drivers, and a signed driver is simply a driver that the Microsoft Windows Hardware Quality Lab, or WHQL, has looked at and decided for this operating system that driver shouldn't cause any harm or instability. If you choose to ignore unsigned drivers, drivers for which the WHQL has not signed off on, then what you're saying is that anything can happen behind the scenes that you're not aware of that can cause instability to your system as far as drivers are concerned. That's probably not a good idea. The default warn at least brings up a little message and allows you to accept or deny that driver in its installation. Blocking is actually highly secure, and it may be a good idea in situations where you don't really trust the judgment of certain users because they may not know what they're being asked, but they may have the ability or the rights to install things that could cause instability. So you might choose block, but in general warn will probably get the job done, and that is the default. Device Manager is a utility that allows you to go in and look at all of the hardware that is currently recognized and installed. When you first go into Device Manager, this is what you want to see. You want to see each category collapsed in such a way to where you have to hit the plus sign next to a category to see what's in it. If you come into Device Manager, for instance, because some device has been disabled, let's say we come in and we disable our COM2 by right-clicking on it and clicking Disable. Now, whether we expand or collapse that category, every time we come into Device Manager from now on, that category will be expanded. And you can see what we're talking about here. It has a red X. You might also see an exclamation mark next to the item. What that means is that there are resource issues within some sort of question, whether there's a conflict or a driver that hasn't been properly installed, and you can fix that when you see it. But the category is automatically open for you to bring your attention to that problem. It's a simple task to re-enable it if that's all it is. The other thing you might see is a full category that has as an icon a large yellow question mark. If that's the case, then Windows doesn't even recognize what that device is to the point where it can put it in a category. And you may need to know what that device is, or it may have a slightly descriptive name beside it to where you can tell what it should be, and then you can find the drivers for that and get it situated. Then the question mark disappears, and either the category it should be in appears, or it's nestled under an existing category where it should be. So this is a great place to come in and look for issues going on with your hardware. Other things that you might want to come in and look at are if you right click on this, you'll notice properties is boldface. What that means is that I can either right click and choose properties, or I can double click the item and I'll go to the same place. I'll go to the properties for that device. You want to see this device is working properly. You have in Windows 2000 a troubleshooter button. The troubleshooter button is nothing more than a, I see it's working properly, but I'm still having problems with it. Let me see what kind of wizards and help screens I can get to pop up to help me make it work. The other button you'll see here when there are problems is reinstall the driver, for instance. That may occur if you have a driver issue. If we had disabled the device, for instance in the case of the COM port that we disabled earlier, what you'd find then by going in and looking at its properties is the option basically to enable the device. So you could enable it from here. Whenever there's a specific issue in here, the button will change to allow you to get a little assistance or help in figuring out what's going on. Other things you see in here are the ability to uninstall the driver. If you're having trouble with the device and you just simply want to uninstall it, manually reinstall it, or get it to scan for hardware changes to ask you or look for the driver itself and install the correct driver, maybe a newer driver, you can do that as well. You can scan for hardware changes from anywhere. By clicking scan for hardware changes, it doesn't have anything to do with the device that you clicked on. You can click out here pretty much anywhere, even though this highlights scan for hardware changes, really has nothing to do with that item. It will do a wholesale scan for all new hardware and bring up a wizard and help you install drivers for devices that it finds. Other things that you can see in the properties pages for any of these devices are the resources that they're using. There's 4 primary resources that you want to know about. Under the resources tab, you'll have things like your I/O range, which is a set of addresses that is parallel to real memory. It's not actually real memory, it's just a series of addresses, generally 8 to 16 different addresses that the CPU can use to talk back and forth to this device, send it commands and get status updates, things like that. Then there's a memory range, which really is true memory, and this is going to be in the upper area of memory where the device itself can store things like its BIOS or intelligence related to the device, that it can run from faster RAM and not have to run from the ROM on the device. Your IRQs, or interrupt requests, are a limited number of resources that devices need to basically get the attention of the CPU through the interrupt controller. And the interrupt controller is just a chip that listens for these signals on these particular channels so that it knows which device is asking for attention, and they're prioritized. Generally, the lower the IRQ, the better, but we have a cascading effect, so anything once we get to IRQ2, it jumps to the second chip, which is IRQs 8 through 15, and they become higher priority than 3 through 7. 3 through 7 are our lowest priorities in that order. The one that's missing here is the direct memory access. That's our 4th resource. For instance, you know almost always that a floppy disk controller is going to use DMA. So you can come in here and see DMA or direct memory access referred to as a resource here. If you're interested in looking at all resources and not try to go through here and piece together what devices are using what, you can go to View, and you can instead of viewing the devices by type, you can view the resources by type, and this gives you the big 4: the DMA, the I/O range, the IRQ, and the memory range as well. So we can expand our IRQs and see what all the IRQs are being used for. It's not in order by priority, it's in numerical order. ISA works with IRQs, and if at all possible, there is no sharing or conflicts going on with ISA IRQs. PCI doesn't have that requirement. PCI has its own arbitrator, the PCI bridge, that is able to reuse an IRQ without there being a conflict. And you'll notice that when you double click one of these and look at its location, it gives a unique location for this one versus the other. If we put these side by side, you'll see that there actually is a difference between them. Even though they look like they're the same device, it says they're both location 3, but the PCI bus device and function numbers as a whole are unique. We have 010.0 here and 010.1 here. So that tells us that PCI knows the difference between these two devices, even though they appear to be the same. So PCI is able to do that, and PCI will not reuse an IRQ that is currently being used by ISA normally, unless it's just a placeholder like this. So you'll find very often that whatever is used by PCI down here will not also appear up here. This is a rare case where there's a system level process that's running there, and that's okay, but that does not confuse the ISA. PCI takes care of that. So you'll find that it's easy to go through here and see an ordered list of each of these resources, and that sometimes helps you find issues and understand where things are at, so that you can stay away from those things if you're trying to resolve conflicts and find a better place to point one of these devices for different resources. So that's Device Manager. Device Manager also has become, with later operating systems, a great place to reinstall drivers and to do that at will. From XP on, you can go in and actually roll back drivers, and by rolling back a driver, it remembers the last driver that was used, and if that driver was okay and the new one is not, this would be the place to go to roll back your driver, and we'll see that in XP. 2000 didn't offer that feature. The rest of the system properties consists of user profiles. This gives you a way to go into a user profile and perhaps make it a roaming profile, where the profile files themselves actually exist on a central server, and wherever you go you can log on as yourself and see the same desktop and favorites and all those things. But normally it's just a local profile, which means that it's good for this system. It will look that way here. If you logged on somewhere else, you'd have a different local profile there. Your desktop would look different, etc. You can always set it up the same, but they're not drawing from the same set of files. In the Advanced tab, very important as well, we have three main sections here. We have the Performance section, and under Performance Options you can see a brief list of what types of things it's telling you that it does. But if we go into Performance Options, the two main things are whether or not you want to optimize performance for applications, very good for workstations, client type systems, or background services, which would be ideal for servers. Servers need to optimize the use of the resources for the background services to run, because there's really nobody sitting there at the terminal doing things on a regular basis. Virtual memory is a very important topic for the A+ certified technician, and it's important that you understand a couple of things about virtual memory. Virtual memory is not real memory. The page file, the swap file, whatever you'd like to call it, is a file that exists in the root directory of the drive that has paging turned on for it. If we click the change button here, you'll see that it has one on drive C. So I would expect to be able to go to my root directory of drive C and see this page file of approximately 192 megabytes. It's called pagefile.sys, and that's the name that we still use in today's operating systems. So virtual memory is nothing more than a file on the hard drive that stays contiguous, that the operating system knows what to do with, that is a backup for your chip memory, your actual RAM. It is not a substitute for it. It cannot operate as well as it. So this is not a replacement or the same thing as RAM. This is a crutch for when RAM is no longer available. For example, in the old days with the Windows 9X operating systems, for example, you would see a message come up that you were out of memory when you tried to open another application that would put you over the top of your available memory. Well, with virtual memory, you don't see that message. What happens is behind the scenes, the operating system says, sure, I have plenty of memory, go ahead and run. But what really happens is the least recently used applications, instructions, and data are pushed off to this page file, and memory, real chip memory, is made available for the new application, which is only a band-aid, because as soon as that other application comes back and wants to run, we're going to need to shove somebody else out of real memory and pull that application's information off the hard drive. So as a result, you're not really allowing all those applications to run in memory at the same time. You still have to shuttle things back and forth to that file. They cannot run from the file. They must run from real memory, which causes page faults, something that you can actually go into Performance Monitor and watch. And if you have too many of them, the recommendation is to upgrade your real memory, upgrade the chip memory, so that you're less dependent on virtual memory. But it is a way at least to make things continue to run, albeit maybe at a less favorable performance level. So if we were to go in here and change our virtual memory, there are certain rules of thumb that we should use in setting the minimum and maximum size. These sizes were set automatically by Windows. I personally did not go in and select those. And when you are manually setting these, you should use the same rule of thumb that Windows uses. That is, the initial size, or the lower end, which means that the file can never be smaller than that, should be 1.5 times physical memory. Remember, we had 128 megs of physical memory in here. Well, this is set to 192, which is 1.5 times 128. The upper end should be 3 times physical memory, or basically twice the 1.5. So you see the 384 is twice the 192. So easy enough to just double the number you start with. If you can figure out with or without a calculator what 1.5 your physical memory is, you can easily just double that number and get your maximum size. This allows your page file, as you start getting busier and busier and running more and more stuff, this allows your page file, as you get busier and busier and start running more and more stuff, to expand with you, and you don't have to get the out of memory message. And you'll see Windows pop up every once in a while and say, hey, we ran out of memory, or virtual memory, we have to expand the page file, and it warns you that it's doing it, just so you can see that you're really kind of pushing the resources of your system, and you can decide at that point if you want to allow it to continue to do that, or if you want to go ahead and upgrade your real memory. Also, back in Windows 2000, you could actually set the size of your registry, and this was also a good idea to give it some breathing room as well. So we see our maximum size, which is configurable, is pretty much more than double the current size. So we've got plenty of room to grow. Also, in the Advanced tab, we have the Environment Variables section. The environment variables allow you to change how the variables that Windows uses in dealing with and allowing applications to deal with the file structure and other aspects of the operating system are handled. For instance, temporary folders, we don't know if an application is going to call it temp, T-E-M-P, or just TMP. Either way, it's going to be pointed to the same place. So these are variables on the left here that have certain values, and those values are checked on by applications and processes of the operating system that need to know what their values are. And for instance, we can have a nice generic windir, which is C:\WinNT. We don't have to know if it's C:\WinNT, or if it's C:\Windows, or if it's C:\Win, or whatever. All we need to know is the windir variable name, and we can specify that instead of the actual value, and it's reconciled to the actual value. So it's a very helpful area, and we used to have to edit the autoexec.bat file. So for instance, if you click on one of these variables and click edit, for instance the path, which just allows you to make sure that you can run something from wherever you are. You don't have to be in the actual directory where the application is. You can run it from elsewhere, as long as that directory for that application exists within the path itself. and we separate individual fields with semicolons. So I can add to it, I can take away from it. We even see a reference to variables within other variable values. For instance, the percent on either side of system root says look up the variable called system root and put its actual value in place. So if you look, then system root must be c:\Win2K, and that has the same value as windir in Windows 2000. Later operating systems, you actually get the system root variable to appear in this list. So that's very helpful when you're trying to change the permanent functionality of the environment variables. Otherwise, you can go out to a command prompt, change them temporarily, see how they affect performance or functionality, and then when you exit that command prompt, they disappear. Your changes disappear. So that's a nice testing environment for you. The startup and recovery area of this tab gives you some very important options as well. For instance, if I have multiple operating systems that I can boot to, I can select the default one from this list. I only have one, so it's going to do that automatically. And if it needs to display a list of operating systems, by default it will do it for 30 seconds, and I can reduce that if I would like, or I can increase it. So however I would like to handle booting up to my multiply installed operating systems, if that's the case, I can choose that here without having to go through and edit boot INI or do anything messy that I might make mistakes with. Also under system failure, a couple of things that you need to understand. For instance, we can write an event to the system log, and we'll see what the system log is in a moment, if we get a blue screen. If you've never heard of the blue screen of death, you're lucky. It's something you don't want to see, but it's something that happens from time to time, and you need to know how to deal with that. Writing an event to the system log is very helpful, especially if you automatically reboot. If you automatically reboot, you may never see the blue screen, but it may have still happened. And as a result, we can get rid of the automatically reboot. We can still write an event to the system log. That's fine, and we should do that so that we can look back over time and see what's going on with the system and what might be malfunctioning. But automatically reboot is probably something you want to keep checked if you have a user that's easily upset by errors and things like that. But for your use, you might want the blue screen to wait until you get there and actually see what it's trying to tell you. So you can get rid of that to do that. Also, we would like to make a dump of physical memory once the blue screen occurs, so that we can possibly take that file, the resulting file, in this case a small memory dump results in a file called mini dump under the system root folder, which again in this case is c:\Win2K. So you'll find that file right under c:\Win2K if it exists. And we can actually go into kernel memory dump and complete memory dump, and we'll see the name of the file changed. Memory dump is what is used for both the kernel and the complete memory dump. So we would probably want to overwrite any existing file, or else it could get very, very large and very complex to look at. We just really want the most recent contents. In this case, we don't get that option for the small one, but this is the default, and that would allow you to send this to Microsoft Tech Support or somebody else who is acting as your tech support that understands how to decode or even just manually read those files. So that's it for system properties. Again, you really should, in all operating systems that you deal with, all Microsoft operating systems, know exactly what's going on under here, as well as each of its tabs and what's going on within each of those. Going back to the Start menu, there's a couple of things that you probably want to be familiar with in here, in addition to how to get to the control panel. But one of those things is available through the control panel. So if you open up the control panel and notice that you have an applet under here called Administrative Tools. Under Administrative Tools is your computer management, as well as a number of other things. For instance, Event Viewer. You might want to go into Event Viewer, which we will do, and look at a couple of the types of logs that it creates. And so with computer management, where you're able to go in, for instance, and see a different way of getting to Device Manager. We see the hierarchical tree over on the left and Device Manager on the right, so it's about the same. We can still get into View and do resources by type. We can do everything here that you could do in the other Device Manager, but you have other things going on here as well. There's Event Viewer. We have a way to change the local users and groups, add users and groups, change passwords, things like that. Also, disk utilities are here as well. Disk management for partitioning and formatting drives and partitions volumes. And defrag. Our defrag utility is under here as well. Under services and applications, obviously the most important of those in this case would be services, and that would allow you to go in and change the startup mode of your services. There's 3 of them. You can either have them disabled so they can't start ever, or you can have them set for manual, where normally you have to go in and start the service yourself, or you can have it set for automatic. If at all possible, if all dependencies are in place as the system boots up, a service set for automatic mode will start up automatically every time you boot. So we can get to our services that way. The other way that you can get into computer management that's a lot simpler than the multiple steps going through Control Panel and into Administrative Tools is simply to right-click on My Computer. Instead of clicking Properties, you click Manage. Manage actually gets you right into computer management, the exact same display that we just saw. So Administrative Tools is very helpful. If you don't want to go into the Control Panel to get to your Administrative Tools, that's okay. You can actually get to it from the Start menu if you install it, and it would have to be under Programs. So if we don't see Administrative Tools under Programs, simply right-click the taskbar, go into Properties, Advanced, and right there at the top, Display Administrative Tools under Start Menu Settings. Now, when we go into Programs, Administrative Tools is there, and we see all of those items that are in there. So that's a lot quicker. And if we just right-click anywhere here and sort by name, Administrative Tools takes its proper place in alphabetical order under Accessories. So that's helpful on many occasions. Okay, so let's take a quick peek in the Event Viewer then. And let's look at the types of things we'll see there. First thing to notice is you have 3 types of logs. You have an application log here, and the application log's job is to hold events arising from applications themselves that are fairly separate from the operating system. Some of them can be applications that the operating system brings with it, but for the most part this is thought of as being issues with applications. And you can have warnings, you can have informational things, you can have full-blown errors, and those 3 types of things you may want to learn what they mean. Just double-clicking any of these brings up a more detailed set of properties for the event. You can look online for what the event ID means. You can get more information if you're not seeing what you need here. So there are utilities online for that, most of them free. The security log is set up to monitor any events that an individual will have to go through and use any sort of privileges or rights. You can also set up auditing of object access. If you want to know if any or all users are trying to access a folder that you have attempted to secure, whether they are successful at it or whether they failed at it, you can set up auditing for that, and those results will show up here. You have to be careful of how much you audit though, or this can get very full. And you may have to save the results and empty it every once in a while in order to keep it from overflowing and causing older stuff to be deleted automatically. So that's something to watch out for. The system log is for the operating system. Anything inside the operating system, actually in the kernel and in the operating system proper, is going to generate system log events. So you'll see some of the sources over here very obviously are built into the operating system. Going back to the Start menu, you have a run line here. You may be familiar with that, and if you're not, very commonly we use that to run our command prompt. There are other ways to get into the command prompt, but CMD is what you would type to open up your command prompt. Another way of getting there is through Start, Programs, Accessories, and it's right on that menu as well. So in the command prompt, something that you tend to do quite often when you're dealing with TCP/IP issues is run ipconfig, and we can do that from here. Tells us what our IP information is, and we can see that we're currently looking for IP information. We just haven't seen a DHCP server. There's no static settings. That's why we get the APIPA addresses, automatic private IP addressing, or APIPA. 169.254 is the telltale sign of that. So we're not on the network right now. We're not trying to communicate outside of our own system right now, and that's fine. Otherwise, this would be an errored situation. We would need to reconcile that by figuring out why we can't communicate with the DHCP server. Or we'd have to go in and set up static addresses ourselves. If you want to see more detailed information, of course, ipconfig/all is what you'd want to type in. And what this shows you is everything from your own MAC address to what DHCP servers you might be using, who your DHCP, who your DNS servers are that the DHCP server has given you, things like that. So you'll get a little bit more detailed information, of course, because we're not connected. We don't see that advanced information, not a lot of it. You see NetBIOS node type is broadcast here. Could also be point-to-point, could be mixed, could be hybrid, but we see that we're in broadcast mode. That would be handed down by a DHCP server as well, and if we had one, it would probably change to hybrid very commonly. One thing to be aware of, certain commands must be run from an open command prompt. For instance, take ipconfig for example. If you try to run ipconfig from the run line like we did command, you'll notice the window pops up and disappears. That's actually normal. That is a non-error situation. So don't think that something is wrong just because the window pops up and disappears on you. The ipconfig command ran and it terminated. And because you didn't say, I want the command prompt to be open, then it closed. So running the command prompt first very often with many commands is necessary instead of trying to run them directly from the run line. Two more fairly advanced concepts to go over just in the introduction here of Windows 2000 are the Task Manager, which you can get to by right-clicking on the taskbar down here and choosing Task Manager. And in a moment I'll show you the Registry Editor, an area you probably don't want to go into unless you know exactly what you're doing. You can disable the system or just cause it to be unstable. But in the Task Manager you have three tabs. You have Applications, and if we were to run any application we would see it pop up here. We opened up My Computer, and notice how Task Manager always stays on top, so we can't get My Computer to appear on top of it. But it shows that My Computer is running. If I were having trouble exiting My Computer, I could come in here, click on it, and simply say End Task. It's a great resource for that. Now, with no applications running, then we shouldn't have any processes running. Well, think again. Many processes go into making Windows run in the background. For example, if I order it by image name, clicking it twice, the first time gets it in descending order, second time in ascending order. Do not stop Explorer.exe thinking that it's iExplorer. iExplorer is your Internet Explorer, but Explorer.exe is all of this. So if we stop Explorer.exe, we lose our desktop and pretty much any access to it, and probably any unsaved data. So you want to be very careful with what you come in here and stop. So these are the processes behind the scene. You can end those individually just like you ended a full application. Under the Performance tab, we see things like CPU usage and memory usage. Very simply, how much of my resources am I using? how much am I at risk for going over the top and causing system instability, things like that. Back under processes, if I was really interested in what's causing all of this CPU usage, which we don't have much at all, but if something is really pegging that graph on the performance tab and we wanted to see what that was, just like we did with the image name, we can do with the CPU column or any of the columns. At first, it puts it in descending order. We can see that the system idle process, which is basically just a bucket for the CPU time that's not being used by a process, not actually a process itself, is currently holding most of the CPU time, which is good. And we see that the order of these processes changes every once in a while because it is in order by usage, and some of them will go down to 0, some of them will pop up to 1, 2, or 3, and in certain cases some of them will take the place of the system idle process and be abusing or overusing the CPU time, and you may have to stop that process to restore system stability. Another thing to notice while Task Manager is running is you do have this little graph down here on your system tray, and even if I were to minimize Task Manager, I would be able to get back to it from over here whenever I wanted to, and I can hover over it and see my CPU usage on an ongoing basis, so that's kind of nice. The other thing that I mentioned was the registry editor. Best way to get into that in Windows 2000, there's a couple of options that you have, and you should know the difference between them. With XP and Vista, there is no difference, just the name. One is regedit. Regedit is an editor that allows you to search and do certain things to registry entries, but there's not a lot of things like security, setting permissions and stuff like that within regedit. For that you would need regedit 32, and be careful when spelling regedit 32. There is no I. REGEDT 32, because Microsoft likes to keep names to 8 characters or less. So regedit 32 looks a little bit different. Comes up in a cascaded window of all of your what we call hives. In HKey we can think of as a hive of keys. These are all keys underneath the hives, and just like a beehive is a hive full of bees, these H keys are hives full of keys, and just about as dangerous as a beehive as well, so you need to be careful. But while you're in here you can do things like change the permissions, and we have a lot more stuff. Security has its own selection in the menu here, for instance. A lot more stuff going on here, but it's a lot tougher to find things. We can't simply do a search, so you want to know what you're doing when you come in here. You want to know exactly where you're going. So with XP, they combined the functionality. You can do all the things that you could do with regedit 32 within the program that looks like regedit. So it's a lot more attractive, which means it's a lot more deceptively easy to use, luring people into the danger of using this. So the registry is made up of 5 primary keys. You have the HKey class's root, which for the most part is just your associations between extensions and the applications that run them. For instance, if I want to change my text extension to run with WordPad instead of Notepad, it would show up under class's root once I was done making that change elsewhere. I would not make the change here. There are only 2 other what we might call unique hives, and then the other 2 are based on those. For instance, HKey users contains all users that have ever logged on to this machine, and then HKey current user contains the contents under the user entry. As you can see, very similar key names, and they're all keys. No matter how many levels down we go, they're all considered keys. And we see then that those keys for that user are copied directly under HKey current user. Same type of thing happens with the local machine in the current config. The local machine is everything hardware, software wise that the machine has to collect as it's booting up. Things like plug and play and all that might not show up here. Things that are transient might not show up here. Where we would see those, as well as a copy of all the things from local machine that apply to this actual boot up, would be under current config. And this is where we would see things like the hardware profile that we chose. It would be copied under current config. And so the local machine is always more complex than the current config. The current user is less complex than users, and you can see why. Two of these are based on the other two. As a practical application for why you might come into the registry to begin with, let's look at a couple of these hives and see some keys underneath that we might look for on a regular basis. First, we'll expand this to full size, and we'll give ourselves a little more room over here because we really are interested in seeing the whole hierarchy that develops here. For instance, if you look at the local machine, there are certain keys under here that you'll always see and that you'll become familiar with. For instance, under software, there is a Microsoft key. Under Microsoft, of course, what kind of Microsoft would you expect? How about Windows? Windows current version. Under here, you will tend to see run and run once keys. Run once is if you were to reboot, whatever you saw under here, default doesn't count. Whatever you saw under here on the values, we call it values and their data. On the value side of the screen here, that would run the next boot, and then it would disappear. So something may have been in here and it ran when we booted up, and now it's gone. But under run, this runs every time. And because we are, and as you can see down here, it's keeping track of where we are. My computer is the name of this whole database, coincidentally named the same as the icon on the desktop. No relationship really that we should draw from that. HKey local machine, sometimes you'll see that HKey LM in other places. So HKey local machine, software, Microsoft, Windows, current version, run. That's what we're currently looking at. You see the little open folder icon. Under here, these two things will run every single time that we boot up. And if we're having trouble with one of these, we can come in here and delete those, but you really should know what you're deleting before you do so. Maybe tech support told you to do so, and that's the only way to regain system stability, or maybe you just know for yourself that that's what needs to be done. But be sure before you delete a single thing or even add anything under here. The other place in a similar location to this that you might look for a run and a run once is for the current user. So if I look under current user, there's a software key. There's also a Microsoft under there, and there's Windows, of course, current version, and here again we see a run once, but we do not see a run. This particular user has not ever installed anything that runs specifically for the user. The things that are running will run only for the hardware, and that means that everybody will experience those things running as they boot up. So there is a run once, something was done here, so that run once key was added. We might actually see a run key should we come back in here after the system is used a little bit more, but for right now no run key was ever required, so it wasn't created. So that's the registry. Treat it like a power supply, the software version of a power supply. Don't come in here unless you know what you're doing, you've been trained to do something in here. You really can completely destroy the stability of the system by doing things inside the registry. There's no undo, as you see. There's no way to undo any changes that you make. So be very careful in the registry. Stay out of it unless you absolutely need to be in it. So that's the introduction to Windows 2000. There are many more things to learn about Windows 2000, but the book shows you many more things about all the operating systems. It also shows you the things that are important for A+ certified technicians, and we'll continue this discussion with XP and then follow that up with Vista.